Chapter 11, Liquids and Solids, Exercise 11.41. Part A, P4 molecules. There's no dipole in P4, so there's going to be only dispersion forces between those P4 molecules. COF3, we have both dispersion and dipole forces. Again, there's dispersion forces just between any atoms or molecules. And this molecule, chlorine trifluoride, has a non-zero dipole. Therefore, we have dipole forces between those ClF3 molecules. Why does ClF3 have a dipole moment? I have the molecular structure here. This is the molecular structure for chlorine here, fluorine, fluorine, and fluorine. And these three bonds are all polar. The polarity of these two bonds roughly cancel. They roughly cancel, but this one is not cancelled. That's why chlorine trifluoride is a polar molecule. Let me see if I can show you the lone pairs. We can see two lone pairs on chlorine. Chlorine is surrounded by a total of 10 valence electrons, 5 electron groups, so its electron geometry is trigonal bipyramidal. So you have a triangle in the middle and one bond pointing up, another bond pointing down. Alright, so that's why this is a polar molecule. The shape of this molecule is called T-shaped. It's like a T. N2O. N2O is fairly complex. N2O can have three different Lewis structures: double bond, triple bond, single bond, triple bond. Well, what's in common? If you look at the total bond order, 2 plus 2 is 4, 3 plus 1 is 4, 1 plus 3 is 4. So they have something in common. Why do they have the same total bond order? It's just because to make each atom have a octet structure, we need to overall have the same number of shared electrons. Therefore, the total bond order should be the same. This one is the most stable because, number one, we don't want too many formal charges. So this one is the least stable Lewis structure. There's two. They are tied regarding the number of formal charges, plus 1, minus 1, plus 1, minus 1. But over here we have minus 1 on the more electronegative oxygen, right? And here minus 1 is on the less electronegative nitrogen. So this is more stable than this. Now if we look at this structure, obviously because of the formal charges, this is definitely a polar molecule. We'll have dispersion forces and dipole forces. We don't have hydrogen bonding. This one has hydrogen bonding. This is ethanol or alcohol, so we have dispersion. This molecule has a dipole moment, so we have dipole and also hydrogen bonding. I think we need to submit all the answers. Again, N2O is a polar molecule based on its Lewis structure. We need to submit this one. ClF3 is a polar molecule, T-shaped. This one is polar. N2O is polar because of the formal charges, mainly the formal charges. But also the electronegativities are different. Over here, all three. So this ethanol or alcohol, ethyl alcohol is polar, and also we have hydrogen bonding.